Hello, hello. Hi, everybody. Just doing a quick check before we get started. Just going to make sure this is all fine. One sec, everyone. Give things a bit more color. Thank you. Oh my God. There we go. Too bright. Cool. Okay, that should probably do us today. Hello. Welcome. Welcome to week 5. It's nice to see everyone. Obviously, we have about 30-40 people here today, which should be fun because we're going to have some fun. We always like to have fun here in our little 1531 lectures. It should be pretty smooth, so I'm not expecting anything absurd today. Obviously, we will be talking about iteration 2 today, which should be fun, should be helpful for a lot of people, ideally. But again, time will tell whether you enjoy it or not. All right, we should be back. Sorry about that. I have this strange problem with my recording software where it kind of like it kind of freezes now and again, and I haven't been able to figure out why. I've reinstalled it. I'm not exactly sure what's up. Maybe I'll ask the uni if they'll finally give me a computer. That'd be nice. Yeah, so someone asked now, the question is, are we doing file systems or databases? I don't know. We'll get into it. I guess that question will answer itself. So let's get going. First part, full stack persistence. What a title for a lecture. So the crux of this lecture is that we're learning about full stack development. The first kind of lecture we did on this was the Express stuff, where we learned about Express.js. And full stack, again, remember, it means looking at a system from the top to the bottom. So that's like from how everything's stored all the way through to how the user interface is for the user. And in a lot of ways, your project is a full stack project. That's what you call it, because you're not just you're working on a layer within a full stack project. But if you include your layer and the front end, you get a full stack project. Now, the part of it that we're talking about today is the data layer. That's the layer at the very, very bottom. So data is a super critical part of nearly every single software system in the world. So it's important to understand what we're working with. We're going to be talking about data generally, as well as the topic of persistence. So firstly, data. Data, by definition, is just stuff. Like, they sometimes talk about, data's raw stuff, which kind of makes sense, like when you read a telescope sensor, or, your car collects data from the tires. It's all just kind of raw things that might implicitly have a meaning, but maybe aren't as processed. And from data, we can gather information or insights that allow us to make decisions, right? So data into information into decisions. That's the usual flow of data in most systems. It's a very high level look at it. However, specifically in software, data is used across the entire application to do stuff, right? It's kind of self-explanatory. It's like, you can't have a program if nothing's being stored. The real interesting questions are like, where is it being stored and for how long is it being stored? But regardless of that, we all kind of understand that data is becoming a bigger and bigger topic in the world, in the sense that, when we think about science in particular, data is becoming a bigger element of it. I remember reading something like 5 years ago now that said like the average science graduate, about 50% of science graduates consider an understanding of computing and data to be critical to their field and their learning. So data itself is a fairly big topic. Now, when it comes to data and applications, this is kind of a little more on the theme of computer science and stuff. I said before, data is part of every software application. If you don't think you've interacted with data storage in some way, you've made variables. However, when we refer to data in the context of software, we're typically referring to a data layer, and that is the part of the software system that's focused on storing data and maintaining state for a long term. What I mean by that is, if you look at kind of like computer or software architecture, at the very top of that, you'd have, it's just everywhere, right? Like when you write a C program or a JavaScript program, when you have variables, you are storing data in RAM on your computer, right? some kind of system memory. That data, when you turn your computer off or restart it, disappears, right? It's temporary throughout the life of your program. You have data at even lower levels of the computer, like obviously things like CPUs, and those systems have caches and registers, which are all just a way of storing data. Because obviously a computer is just a big collection of spaces of data where stuff is operated on. You can get into like, well, there's some data in the CPU, then there's some data in the RAM, and so on and so forth. But the point is, in the context of what we're talking about here, data is referring to the layer of our software where we store data long term, right? And I think that quote there, storing data and maintaining a state for longer term, is important. Colloquially, you'll understand this is like your hard drive on a computer, typically. It's that thing where you store data on it and you can restart your computer and it's still there tomorrow. And applications have this as well. So if you think about an application, you might have like an interface, and then you'll have a couple of layers underneath it. Maybe there'll be like the business logic layer, which is kind of like what you're writing in your assignments. That's where you're essentially taking specific you're defining capabilities specific to your business or your operation. And then under that, you might have like a services layer where there's, think of it like Express and things like that. And then further under, you'll have the data where stuff is stored, basically. And that forms a lot of applications. And the thing is, again, you could get into specifics like, oh, on the front end of websites, there's like caches and cookies and things like that. And that's technically storing data. Like, that's true. But at a really high level, the point I guess I'm trying to make is that most applications follow a pretty simple model where the front end is stateless. The application itself is somewhat stateless, as in, the code you're writing or have written for iteration 1 doesn't store anything. But underneath all that, we do go and store something later on. And that's kind of what we're going to be talking about today, is actually how do we store data for our system at the bottom of it all. Big oversimplification. If anyone's built applications before, you'll know that this is an oversimplification. But that's the point. We're just trying to get the point across that nothing you've really done to date is probably dealing in any material way with storing data. It's kind of one of the funniest things about, I think, a lot of courses at uni. I've been very kind of open in sharing that, I think there's 3 problems with our uni degrees generally. It's pretty common across most universities. It's like, and one of them being that we don't do enough with the storage of data. What I mean by that is you go outside of uni, the vast majority of times you build services, you're going to be building a service that you can't just run it over and over again, because whenever you run it, it changes the underlying data in some way. And that's really interesting, because if you think about iteration 1 as a mini assessment, you could just kind of run your jest test over and over, and it never mattered because your thing wasn't storing anything. But imagine if every time you ran your jest test, if you registered user A at b.com and then you ran it again, it was like, sorry, I can't register user A at b.com because they already exist. In reality, obviously, you can go and wipe the database. That's kind of, what we do with things like the clear function. But the point is, really thinking about this in more detail is just one of the small prerequisites of what we want you to finish this course learning. But we do treat it pretty light. Now, in terms of these data layers, these things that store things fairly persistently, or at least most often persistently, you'll hear the word database used quite a lot. Now, someone might say data layer, data store, database. These are all words that mean the same thing roundabout, one way or another. But if we just focus in on database, because that's a pretty common term that you probably heard, it's a word we use to describe the storage of data. And typically it's to do with persistent data being data that exists beyond the life of the state of the program, which I think we talk about in a sec. But there are 3 main ways we can store data generally in applications. We can either store data in memory, not persistent. And what I mean by that is that typically not persistent data will be cached data. So what that typically might mean is like, so let's say a good example is the Git run website, the website that you use to get your leaderboard results. How that actually works is there's a lot of data that comes from a database. Well, there's some data that's generated somewhere, but rather than generating it every 1 second when every student asks for something, we actually store it in a little like in-memory database, which is like, it's not, if the server gets reset, that database gets reset as well. The cool thing about that idea is it's actually not too dissimilar from what you've been doing in iteration 1 with your data store. Because Because if you think about it, your data store basically acts as an in-memory database. It kind of behaves like a database. Like, you treat it like it's something that stores data forever, but it doesn't really. You know, when you restart your server, it's all gone. So it's non-persistent in-memory data. But the other ways that we can store data are types of persistent memory, and we've got two here we make reference to, which is either in file, where we store stuff directly on the system, or it's through an actual like scalable industrial database environment. Now, there are many database environments. We have things like MongoDB. We've got things like, what is that, Google Fire, it's called Firebase. Firebase has a bunch of other stuff for it as well. Naturally, you've also got things like PostgreSQL. You've also got things like MySQL. You've also got things like MSSQL. Like, it just kind of goes on and on. There's lots of different pieces of software. Like anything, there's lots of different programming languages. But these are all quite heavy. The further you go down the list, the more powerful they get, the more performant they are, but it's also a higher barrier to entry. It's harder to kind of get started because there's a learning curve involved with it. So, we're not here to talk about databases. If you want to go learn more about relational SQL, you can go study COMP1531. It's a massive elective. It's one of the biggest electives in the school. I would strongly recommend it. It's not very fun. That's okay because it's important. I think databases are a remarkably important skill to spend time thinking about. And if you don't go study it, that's perfectly fine, but go teach yourself in your spare time. If I met a computer science graduate who didn't know anything about SQL, whether it be, unstructured SQL or relational SQL, I would be like, that's probably a pretty important skill to understand. That's not to say that it's going to hurt you. I'm just talking about me. If I met you after uni and you didn't know anything about database stuff, I'd be like, I wish you did a little bit of it because that would be quite useful. So go check it out, even if it's a pet project, even if it's a CSE SOC project, a DevSOC project, something you do in your own time, something you add on to, this course for bonus marks. That one's trickier because you got to get the buy-in of your group. Point is, figure it out in the next few years to learn a little bit about that would be my personal subjective recommendation. Now, databases like SQL are really hard to work with. So what does that leave us with? That leaves us with this middle one where we can actually store things forever, but store them in files. Now, I guess we'll unpack that as we go. So persistence, just a quick wind back. I mentioned this before, but I just want to reiterate. The formal definition of this is persistence is when a program state outlives the process that created it. That actually makes sense because if you think about your application for iteration 1, you start up the application and all the variables inside it get defined whilst the application's running. And then when the application ends, all the data that it was using ends as well. However, if you find a way to store the information that you generate whilst your process is running such that you can get it later, you effectively made the state of your program outlive the process that created it. That's pretty cool. In general, you could interpret this a bunch of different ways, but we are very simply interpreting it in this course as persistence is when you define data to disk. Disk meaning the file system in some way. Now remember, all these applications like SQL and those databases, they all define it to disk. They just abstract that away from you, right? So all of that stuff's defining it to disk. For sure. Can we modify our project to persistently store data, and how would we do that? That's a really interesting question. So for iteration 2, we require you to add a persistence layer. Now, we don't want you to go and add something complicated like an SQL database. That would be very silly of us to make you do because we would probably have to have 2 or 3 weeks of lectures on SQL just to get you really comfortable with it. So to keep things really simple, we ask you to load and store the state of your program in a JSON string that's stored on file. Now, this actually makes a great deal of sense because if you think about how you might, like if I said to you right now, I want you to store data persistently in the file system, what you might jump to as an idea is you might go, well, I'll just store it as a text file. Okay, that's okay, but the problem with the text file is that there's no structure to it. It's back to what we mentioned about protocols and data interchanges and standard interfaces. You'd have to define a way that you're going to structure that text file so that everyone could understand it, you know? And then you'll probably have to document it. Then you think, okay, text files are unstructured. That's not good. What about a CSV? We've all worked with a CSV at some point, a comma separated file, you know, big fat file with a lot of commas in it, new lines. That works well. That's a structured thing. That's pretty good. But then it's like, well, now if we can't represent information in the format strictly of basically a table, it's useless to us. So the logical result of that is that we go and make something in JSON. And this works really well because if you think about iteration one, you stored everything as an object anyway. Okay, cool. Well, now for iteration two, what if we just take that data store that you have and dump it in a file and then load that file? That's a really interesting concept. So we're gonna, I'm gonna use some code samples earlier in the week, and we'll go through this, right? This is basically what the rest of this lecture is. It's quite short and straightforward. We're gonna go and make something together. Now, I don't think we have explicit code for this one because we don't really need it. I might steal something from the other lecture. Now, just while I'm getting that together, I want to answer a question as well. I'm just gonna go use this in the 4.2 stuff. What we got there? Okay. I might just modify this one, crud.ts. So let's say we've got this file here called crud.ts. Now, yeah, I'm just gonna go simplify some routes here. Really simple. Yeah, we'll go start with one route and we'll go from there. We'll run it on port 3000. Now, someone has asked in the chat, are we allowed to use SQL though for the project? So you can use SQL if you'd like in the project. There's, I guess, two caveats to that. One is that you need to make sure all of your group members are extremely happy with it. And I would get that written down somewhere just in case there's any like problems, and get everyone in teams to be like, yeah, I'm really keen, let's go do it. The reason is because the rule that we have applied historically in the project is that we don't want groups doing anything that is harder that all group members don't agree to. Because sorry. Just reading something very important. Okay. Don't worry about that. Thanks for that. I don't normally check things, but that one was important to check. So basically, we need SQL. Sorry, I was on SQL. So with SQL, if someone in your group's like, that sounds hard, I don't want to spend the time, the group can't do it, even if 3 out of 4 of you want to do it. Okay, so that's just life. I mean, it's hard. And the other reason I'd say it is because SQL is a significant overkill for this project. If I was doing this project myself, I would do it exactly as we've done it in the lecture code. And in fact, like when I created this content like nearly 5 years ago now, that was the purpose of it. It was to kind of be like, well, this is not only simple, but it's kind of fit for purpose. If you were making a really simple app, SQL can sometimes be overkill. The Git run app, so the Git run website that you guys get your leaderboard on, I built that. And I built that with a product called Airtable. You can go check this out. I think it's a great product. I don't sponsor them or anything. But I've always loved this product. It's one of the few products of the last decade that really stood out to me. It's basically a database where there's like a GUI behind it. So it's kind of like it's like SQL. It's not really like SQL. It's hard to explain. It's like if Excel or Google Sheets had a really easy to use API, would be the way I would describe it. So you can kind of make stuff in Sheets and modify it, but you can still write code to talk to it. Last week, we talked about how you can write code that talks to, how would you put it? Write code that talks to a server and makes a request, right? That was the API client via code. You can actually do that, but talk to Airtable and things like that. So there's many different ways to solve this. So if someone was like hell-bent on like, we want to use some kind of more interesting system, I will go look at Airtable because it's interesting. And Carl's mentioned in the chat, is it like an ORM? So this is kind of why you should go study COMP1531 or go do your own learning, because it's such a deep topic. So I'll answer this one, but I'll try not to get lost in my own rabbit hole. An ORM stands for relational model. I haven't looked at it in a while. Mapper. An An ORM is basically an abstraction of a database. So for instance, you know how like C and JavaScript do the same thing? It's just JavaScript's a little easier to use, but you have less control. It's like, imagine SQL is C, and then an ORM is like another kind of library or piece of code on top of it that is much easier to use and abstracts it away. So you can also look at those things too, you know? So it's like, if you were super desperate, and 99% of you should not be super desperate just because it's probably a bad use of your time, unless everyone in the group's like, we all want to learn right now and we've got a lot of spare time. It's like SQL is the most hardcore thing and very few people would be writing raw SQL. Then you have an ORM, which you can Google. Really common one that might be good for the project. Again, I want to stress, I'm mentioning this, pretty much no one should probably take this up, is like type SQL, Node.js, what's it called? Type something? ORM. Type ORM, that's right. Type ORM is a great little library. I haven't used it in maybe, well, I mean, I use it every day for work, but I haven't set one up in a while. That can be pretty cool to look at, or you could look at Airtable, or better yet, you could do none of that and just do what I'm telling you in the lecture because you'll find it a lot easier. So if we go back to our code, we've got a really simple server here, npm tsnode, npm run tsnode, crud.ts. Cool, so we got our server running. Now here's the interesting thing. Let's imagine that someone passes something in to each GET request. And let's say that they're passing in a number like this. Request.query.number. Now what I'm going to do is I'm going to, for instance, go and create a little data store up the top here. Const data store. And inside that I might have my usual users thing and my quizzes thing. This should look pretty familiar. And then I might also just have a count for no particular reason at all. There's my data store. And what I want to have happen is that, you know what, whenever someone calls my get apple, actually I should change this slightly. I might make another request. Let's say we have, you know, post, we'll call it, you know, number. Whenever someone does post number, I got to write it out again. You know, equals request.body because it's a post request. Dot number. And then I'll say data store dot count plus equals number, but I'll also have to parse int it, I think, because everything passed in via HTTP request is typically a string. So now I've got a post request called number, and then I'm going to have a get request called number, and all this is going to do is return me a JSON object that tells me the number, or count in this case. So now I'll go and restart my server. What did I do wrong? What did I do wrong? Oop, got it. Cool, so start that up. It runs. Perfect. Now, I gotta go and run this localhost 3000. Now, it's not gonna give me anything on that route, so I need to call /number. Now, when I call /number, I get this nice little 0 here. Okay, that's cool. I need to make a post request though, because I don't just wanna do this request where I get to see the number. Here, I actually want to update the number. So it's like, oh, well, I can't do post requests in a browser, so I'm going to need to use an API client. Now, ARC is the one we use on VLab. I showed you that last time. I'm going to show you a different one today, just to give you a sense that, you know, sorry, I'm just trying to get it working. To give you a sense that there are different ones you can use. This one's called Insomnia. I think it's a bit more advanced, but it's also got a lot of stuff associated with it. So here it kind of is. Now, if I was like, you know what, I really want to make a new HTTP request to localhost 3000. I want it to be a post request. It's going to be to /number, and the body is going to be some JSON in the format number is 3. I don't need that there, so that should be okay. Let me try that out. What happens when I hit send, see if it works. Nope. Unexpected token N on position 3. Maybe it needs to be a string? I don't know. Oh, wait, sorry. I think I understand. My bad. See, JSON, it's like JavaScript, but with rules. That should be it. So I try that one now. Okay, that worked. Now I got an empty object back. That makes sense because I asked for an empty object back. And if I call it 2 more times, what do we think is going to happen if we load up the web browser now on the other get route? Because remember, everything in a web browser get route, we get a null. Oh no, we got a null. Why did we get a null? That's not good. It's time to debug our program. Let's check it out. Let's just console log number. Whenever I console log stuff, I usually like to duplicate the variable name with some text in front of it so I can identify it. I'm going to restart that. Sounds good. And then I'm going to bring up my API client again. And I'm going to hit send. I'm going to see what it prints out on the terminal. Numbers undefined. That's not good at all. So what am I going to do now? I might just say console log request.body. Because after all, that's kind of where I expect stuff to come through. Has anyone figured out what it is yet? I click send here. All right, request.body number 3. Request.body.number. What happens now? Because we can demonstrate that it's there, fine. Restart that again. Request.body number 3. Interesting. What do you think's going on here? Because if I do number, we get undefined. Oh, that's probably it. There you go. How to work. Cool. Okay. So, I hope I haven't lost you. One sec. Cool. So now we call that once, twice, 3 times. I load this up. It says 9. Perfect. I call it again. I load this up. It says 12. Now the point I'm getting at here is when I close this server and I restart it and then I refresh the page, it says 0 again. Okay, that's not good. Well, we want it to be persistent. Okay, well, how do we make it persistent? Well, I have my data store here. There's a bunch of different ways you can make it persistent, but I'll show you one of the easiest ways you can do that. At the end of every one of your routes, I'm going to go make a function called save, really simple function, and all it's going to do, right, is every single time someone calls it, it is simply going to import file system from file system. We need to get that particular one. It's going to say file system, write file sync. That's the function. You can Google it if you want to write to a particular file. I'm going to call that database.json, and then I'm going to give it content to write to. Now, just to test it, I'm going to write test into the file, right? Because remember, baby steps when we're programming. So what I want to be able to do here is to open up this, and you should see a file appear in the sidebar, hopefully. My editor's been a bit weird. I have to manually refresh it sometimes. But it is there. It did come up, and when I open it up, there it is. Database.json has test in it. So then I think, okay, well, instead of test, let's just do json.stringify data store. Should be pretty easy, right? You can see it there. Okay, got to restart my server. You can obviously use nodemon if you want to do that quicker. Too many buttons. That, and then, yep, and now I hit send. There's my data store. So I've kind of saved my database here. And then you think, oh, that's amazing, because now when I restart my program, it's going to be saved somewhere. So I go and restart my program, run it again. Is it there? No, it's not there. It's still 0. Okay, why is it still 0? Because even though I've saved it in a file, I'm not reading it from a file yet. So it's like, oh, okay, well, obviously what I need to do now is that instead of defining this, maybe, let's comment that out for a second. What I need to do is say, well, okay, well, when the program loads, I should read from database.json. Yeah, and then I'll print that out. Data equals that, console log data. See what it prints out. TypeScript's complaining. Let me, this is a good example of where I might turn off the type checker because I just want it to run. I don't want it to get mad at me. Okay, so I've got a bunch of buffer stuff there. Typically when you read from a file, it again tries to send you a stream. But in this case, okay, there's the data. And then I want to, object is just the json.parse of the data. So I just open up a file with a JSON string in it and I've got my object. And you know what? I'm just gonna call that data store. And there you go, my program should run perfectly fine now, right? Because I've loaded from a file a string, used the function to turn it from a string into an object, And now when I go and make a call here, 1, 2, 3, 4, should get 12. Yeah, sorry, not 16. So that works fine now. So this seems to be good. If I stop my server and I restart it, perfect. I can refresh it again. It's still 12. Now, one downside of what I've done there is that this works fine until the file is gone. What happens if the file's not there? Why would the file not be there? Maybe the system's been reset. Maybe someone else in your group hasn't got the code yet. Typically, when we create a database.json, we go and also add it to our git ignore. I don't have that file here, but like if you had a .git ignore file, you go and add like database.json because you don't want this committed to the repo, because otherwise as people are doing debugging and testing and you accidentally commit it, you're going to confuse each other. So typically those kind of state-based files won't be committed to the repo. So then you say, well, how can I manage this? Well, I could look up another function that's like if file exists or something like that. So I could say, how do I do that? Node.js fs file exists. Read file sync. You want the sync ones. There you go, read file sync. Perfect. So I simply say if read file sync, if database.json exists, then we want to go do all this stuff. However, if it doesn't exist, what do we want? We probably want it to be a default thing. So I could go put an else here, or alternatively, I could just go and again, there's some small tweaks you might have to make for your project. I could simply say, okay, when the program loads, it's going to create a default data store. Then if the file exists, we will go and read from it and then parse it to JSON. And then just to be good measure, I will abstract out that variable just so my tutor doesn't get too mad at me for repeating stuff in my code. Cute. So now that should work totally fine. If the file doesn't exist, it goes and kind of temporarily it doesn't create a file yet until this happens. Once I send, now the file's been created like that. So it's a pretty simple idea. Carl says, is there a way where we can defer the function so that it saves when the server closes? It's a great question. It is possible. There are going to be like express on server close. There are going to be certain commands like, who would it be? Server.close, right? So you can do something like this, app.close. And all I'm going to do here is just like wave a bunch of times. So you could write this kind of code. Sure, that makes sense. So I'll do, is it app.close? Have I got it wrong? Is that not express? Oh, okay. That makes sense. So here you would say like const server equals app.listen, and then you would say server.close. Yeah, because I guess what you like, express is a library. You can create like an app via that library, and then you could start it on many different server ports if you really wanted to, right? So yeah, they're the server closed. I don't know why that closed instantly though. I don't know if I've done something wrong there. Oh no, that's actually telling it to close. Maybe you can't do it. Oh, that's what I want. Sorry. Process.on. Yeah, so basically what I was probably looking for here is this one, which is that when someone hits Control-C in the terminal, you can do it like this, because then I hit Control-C, or is it Control-Z, one of the two? Oh, it's already running. Oh, I'm probably screwing something up. I was hoping this would be a little more elegant, but the short story here is that that's closing it. So I should say listen. Express listen for server close. Let me finish with where I should have started. The problem with trying to do something on closure is that it assumes that the way that the user is interacting with the operating system gives your program the time and the space to wrap up, basically. So it's like, let's imagine, it's like anything, right? Like you're at a job and you're like, well, before I leave the company, I want to have a party. And it's like, that makes sense, unless the company terminates you like on the spot and walks you out the door, right? So it's the same with the server. It's like you can write code that will like listen for when the user tries to close the server. That's what I was trying to do there. And it can wrap up in some way. But the problem is, what happens if the power gets cut? What happens if the user does like a more aggressive close of it? What happens if the operating system kills the process because there's no memory? All of those things can be really tricky. So usually we would just kind of do it on a per route basis. But it is possible to look at that regardless. There's other things you can do. We've seen some groups do saving based on a timer. I'm not really a big fan of the timer aspect because the problem with the, like, you could go and create a timeout. You can go Google this if you want. It breaks down because the way JavaScript works is it's constantly multitasking. And it's like, what happens if you have 3 data store updates to make? You update 1 and 2. And then JavaScript's like, oh, time to save the database, you know, like slicing it at a really weird time, you know. Be kind of like if you were sending a message to a friend and like Instagram just randomly sent whatever you were writing every few seconds. Like it would just kind of cut you off sometimes, which would be really weird. And then Sophie had the question, do you only need to load data at the start of the program or once inside each function? Generally at the start is fine. Yeah, and people have all kinds of ideas. So what I'd say is like, there's lots of ways you can deal with this stuff, and I like that people are trying it. So for instance, the things like, what about we listen for a server kill? Someone else might say, what about a timer? Someone else might say, what about middleware? They're all interesting, and you can go and explore those with your group if you want. But at the core of it, the one I would just suggest is saving it at the end of each of your functions. It's kind of the easiest approach as far as I'm concerned. Thomas says, don't force methods of killing risk causing file corruptions anyways. Yes, of course. Anytime you kind of kill an app, there's always weird side effects that you can have. But as an app developer, you generally want to mitigate that as much as possible and only leave it to the absolute necessary issues, is what I would say there. Any other questions about this? It's a pretty short kind of first lecture today. Oops, that's the wrong one. My apologies. Yeah, it's pretty short. So we're pretty much kind of at the end of that. It was just meant to be a quick little demo. If anyone has questions, please post them now just before we wrap up. What does process.on mean? Okay, so this is, I want to be clear, what I was writing down here was pretty beyond the scope of what we'd expect you to do. Process is a global variable in Node.js that represents essentially the node process running on the computer. Process has a lot of like process events. Process has a lot of events that happen. Like there's like before exit, disconnect, message, message from like the operating system, warning worker. Like there's a lot here that's all to do with how Node exists within a computer. You know, it's very Linuxy, Windowsy operating system-y kind of stuff. I very rarely interact with this personally. Probably the main way I've interacted with it in the past is going to be to force exit the program. That can be really handy. So for instance, like, you know, if I'm writing a program and someone does something like, if, you know, someone does something silly, I can then be like process.exit 1 for like a failure. But again, we don't really deal with any of that in the course. That's probably more for script writing than it is for like application server writing. Lab 4 shapes, continuous integration is confusing. Could you go over that possibly? That's a great question. I actually don't have a lot to do with labs this term, so that one I probably can't. I mostly spend time on the project. But what I would say is, if you post on the forum about it or a help session, but I'll also ask you, Chow, like what I would say, because I'm just not the right person to cover that in the context of the labs. And you, Chow, did the lecture, so I don't want to speak over that. If you make a post on the forum being really like, hey, lab 4 shapes is confusing with continuous integration. Can we learn more about it? I'll kind of tag you, Chow, after the lecture and be like, can you keep an eye out for these forum posts? And if people need like a quick little Loom video or something like that, can you help them out? But just like, can we really focus on that? So just for the lab stuff and other UChow's lectures, I'll pass that on to her. But just to check, stop breathing. You're talking about, you're feeling cooked about labs for shapes, and that you're all quite stressed about it because you need like a line by line run through the code. I hope I'm understanding that right. I'm going to assume so. I'll pass that on. As I said, please make at least one person make one public forum post that's like, I'm confused about this. Can someone help me run through it? Because I'll point to that. Because if I tell UChow, hey, students are having oh, of the lecture. Okay, sorry. I thought everyone was talking about what quote unquote Fat Larry was talking about. Yeah, okay. So Larry, if you want to go and lab 4 stuff, go post on the forum. Is it fine to use Control-C to close the server? Yeah, so there's usually a few different commands you can use. There's like Control-C versus Control-Z. It depends on the computer you're on as well. So Control-Z is used for suspending a process by sending a signal, signal suspend, I guess, which cannot be intercepted by the program, while Control-C is used to kill a process with the signal SIGIT, which can be intercepted by a program. So as an example, it's like when you use Control-C, you're basically saying to the program, wrap up, wrap up, wrap up, I need to end this. If you use Control-Z, it's basically saying, I don't care what the program does. And you might be thinking, why would I ever use Control-Z? What happens if you have a program where you're listening for which was basically, where was it? I don't remember the file it was in. Right, so say this stuff here about, oh, we're listening for SIGINT or something. What happens if you do that and you write a program where once you hear that the user wants to shut you down, you just start a while true loop and it loops forever, right? That would be bad. So Control-Z's there for like, basically when someone needs to like override you and be like, I don't care if the program wants to wrap up. I don't trust the program. I need it to end right now. Now, just in terms of this lecture code before we wrap up, there's actually not a lot of new lecture code here. So it's just rearranging the stuff we've already got. So I'll probably just highlight the couple of key lines because we've already learned about JSON and we've already learned about Express. So all of this here is just from previous lectures, but if I get rid of that at the bottom. Main thing to notice here is probably the file sync. So there's a library called FS, which is the file system library. That particular library has a few functions on it, which like this one is like exists. So I basically go to a file and say, does this file even exist? Like literally a path to a file. The next one is like, hey, I want you to read the content from that file. However, when it gives it to me in this like stream buffer, which I need to convert to a string. There's a little bit to unpack there. But it basically, yeah, I mean, I would just shortcut that. And just assume, take my word for it, right? Like we don't need to get into buffers. Then here we write to a file. So this one's like the opposite of reading. It's like database file. We say, hey, I want to take this file and write stuff to it, which is this here, JSONified string. Like this really is like the parts make up the whole. That's kind of why this is a really fairly straightforward piece of code, because whilst it's maybe a new ID you've seen, you can probably spend time with it. And if you get caught up on the Express stuff, you can go check it out in week 4. If you get caught up on the JSON stuff, you can go check it out in week 3. There was also some chatter in the chat about Control-Z just suspends and it doesn't kill the program. Yes, no, for sure. That was a bit of an oversimplification just because that's kind of how I see people using it a lot, is trying to Control-Z it to kill it, which is also why you need to be really careful for something like Express, because occasionally if you try and kill Express in a not nice way, it will still be running behind the scenes. So I'd probably say like, you should never really do Control-Z for stuff as like a general casual user. The only time I'd ever do it is if you're like Control-C, you're just like mashing the keyboard and you've been sitting there for like a few minutes and you can't even close the terminal, because closing the terminal will kill the processes involved. Obviously, a lot of this kind of stuff we talked about here is quite advanced and you don't really need to worry about it. Yeah, so a force kill is sig kill. So for instance, you can kill processes in Linux if you want to with like the kill command. You like kill a particular process. Like let's say, for instance, I'm running this, well, let's say right now, right, I've got this server running. I can go and find my CRUD server just by looking it up, and then I can be like, oh, well, there's a couple things here, but I can be like, oh, there's my server. And then if I want to, I can kill that particular process and you'll see that it's gone now and it's not there anymore. So that's me sending a kill command to the server. That actually kills it instantly. So that's in the literal sense going to terminate the program forever without any kind of nice wind down or anything like that. Kill being immediate end to things. But then again, you've got the more kind of soft control C, control Z. But again, you got to have a look because there's lots of stuff to this and we don't really touch on much of this in the course. I think one thing that we could always have in the program more is teaching people about the fundamentals of like operating systems, like things like that, processes and whatnot in a bit more detail. So I know some of it's a little bit hairy or scary for people, but we don't really cover much of it and there's not really much you need to know. So it's pretty straightforward. You press Control C to end your server. That's it. That's all you really need to know in this course. Everything else is kind of beyond the point. But let's take a quick 5-minute break and talk about iteration 2. Hopefully that was interesting about persistence and everything else. If you have any other questions, we can chat after the break. Yeah, sounds good. Hello, welcome back. Over the break, someone said, doesn't it seem kind of suspicious how this guy doesn't use an ad blocker? I guess so. I don't know. I don't know why that makes me suspicious, but it doesn't sound like the dumbest thing in the world, but like, I'm so thankful for everything the internet's done for me in my whole life and how free it's been that I just feel bad getting rid of the things that make it free for me. Like, yeah, someone also said I'm so sleepy. I'm sleepy too, man. God, daylight savings hit me like a brick this week. I woke up at like 8:30 today, which is later than normal, and I was like, like it was a miserable feeling. It felt like it was 6:30 in the morning. It's very strange. It's funny. I used to hate daylight savings when I was younger, because I was like, "What's the point of this?" But I have to say, I sleep really heavily, and I don't really get woken up by light very easily either. But it was only when I spent some time in Queensland in summer, and then I realized that like the sun rises at what, like 4:30 or something in Queensland in the middle of summer, and I was like, "Oh, that's right. There's actually like a massive benefit to it, which is that if you Yeah, light wakes you up. It kind of saves you from the misery of being woken, like, you know, it being like full bright by 5 in the morning. So, anyways, this is unrelated. Let's go. All right. We're going to talk about iteration 2. Good old iteration 2. Iteration 2 is like year 11 in school, is what I always say. It's not harder than year 12, but it sure is the biggest jump you'll deal with in terms of difficulty. It's like that with the project too. Iteration 3 is harder. Of course it is. It's the third part of a 3-part story, but iteration 2 will feel like a bigger jump from iteration 1, then iteration 3 will feel like a jump from iteration 2. So that is kind of what we're talking about today. It's really just trying to get you comfortable with everything. So we're mostly just going to be talking through the spec. There's not really a lot to want to talk about. Like the lecture slides are pretty benign, so we're just going to quite literally go through the spec. The good thing is that the previous videos that you've seen should have taken you through everything around due dates, late submissions, reruns. I think reruns you should all be familiar with by now, or UChao should talk about it, or has or will, or something like that. Demonstrations, you all kind of know, project check-in, you know, blah, blah, blah. There's nothing really that new here at all. Sweet. Cool. So what we're really talking about is just section 4, which is nice. I really like that. It's a nice little contained area. And there's a few things to unpack. We're going to keep some notes while we're talking. I like taking notes whenever we talk about new iterations because I think that it makes it easier to kind of come back to things. Iteration 2, building a web server. So before we even begin, the really simple explanation of iteration 2, it's really, really quite easy. You are taking routes and tests you are taking functions and tests you wrote in iteration 1, and you are express serverifying them. And then you are doing more work as well, writing more functions and tests. That's the core of it, really. Like, we can get into all the little details and stuff. Oh, there's already a video here from me talking. Why am I even talking? That's a while ago now, actually. Damn. Okay. I don't know why they got such an old one there. So, iteration 1, oh my god, iteration 2, big task section. So we want you to make adjustments to your code based on feedback given by your tutor in iteration 1. Makes sense. We want you to change all your file extensions from .js to .ts so you can run it with TypeScript. TS node, sorry. Also makes sense. We want you to implement and test the HTTP Express server in accordance with the interface. Okay, there's a lot to do there. That looks like the bulk of the work. We'll come back to that. We want you to ensure your code is linted. All right, so there's a section on linting. We want you to ensure your code is linted. We want you to continue demonstrating effective project management and Git usage. Also makes sense. It's the same in every iteration. And we recommend, but it's not required, that you remove any type errors from your code. So this is what I was talking about last week in person or online, I don't remember, which is that you can go and run npm run tsc for the strict TypeScript check of your code. And if you do that, it'll point out any errors that exist in your code that TS node doesn't pick up on, right? You don't have to do that. We just recommend that you do that. Which lecture talked about linting? The linting lecture. I'm not too sure. I didn't teach it this term. That wasn't on my list of things to teach. So it should just be on the course website to go and... So I'm just changing the stream quality a bit because it's a little bit patchy. Okay, that should be better. Yes, it should just be on the course website. Kevin says, do we have to go back to our functions and add variable types and changing to TypeScript? You only have to change the file extensions. That's all you need to do to run the code. However, so think of it like this. When you do npm run ts node and actually run your code, there's no type checking that happens. But when you run npm run tsc, there is type checking that happens. If you're not too sure what that means, you can go and revisit Yuchao's lecture on TypeScript because she should have covered it in that lecture, the difference between using ts node and tsc in terms of how strict they are with how they're configured. But the short answer is no, you don't have to go back to your functions and put in types for everything. We just recommend it. Yeah, in terms of the linting stuff, again, it wasn't on my list to teach this term, so I would go and I would go and look at the course website. It's got to be there. So just check out the course website, everyone. Otherwise, post on the forum. I don't run the course, so I don't know everything off the top of my head, sadly. All right, so that's all pretty straightforward. We'll kind of come back to this implement and test the HTTP Express server stuff because there is a little bit to unpack there. Now we come down here. It says running the server. Okay, well, first thing I'm going to do is I'm just going to quickly clone this repository. Right. Let me see. Let's go 1531. I'm going to get rid of my project backend and I'm going to clone it here. Cool. Project backend. Perfect. All right. Now I'm going to npm install as well. So this is what your repos should kind of look like this, right? And what we're saying here is if we go down to iteration 2, you should be able to run your web server just by running. Oh, give me a sec. Got to get this fixed up. Just waiting for that to finish. Back in. Oh, what the hell happened there? I'm probably using the wrong version of Node. Cool. So I got my project backend. Now we pushed a file to your repo here called server.ts. This is forced onto all of the groups. So you all have a copy of this. When you run npm start in your terminal, that is the server that runs. It just runs that server on port 3200. Right? Pretty straightforward. That's all that we'll kind of come back to that. We've talked about servers for a week now in terms of all the different stuff in there. Section 4.3 is on implementing and testing features. This is the same as previous iterations. We want you to write your tests, then write your code. Pretty straightforward stuff too. There's also this small section on testing the interface. What we talk about here is that you'll also notice that we have a couple of new files to see here. I think this really highlights the migration. So have a look at this one here, new echo.ts, right? Like let's say, okay, so in iteration 1, you had a file that might have looked like this. It was a function, it did some stuff, it took in input, it exported stuff, really easy. In iteration 2, we're gonna have to go and migrate that to TypeScript, right? There's slightly different functions here in terms of how they're implemented, but you don't have to go and put in all these types yet. We have talked about this. We recommend it, but you can always do it later. It's the same function. All you'd have to do is change the file extension, right? So it's just a file extension change. However, in iteration 2, these things that we talk about are you go and take the functions that you wrote in iteration 1, like this, and you can go and put them inside your server like this. So this is really important because in iteration 2, your web server will have very similar functionality to the functions you wrote in iteration 1. And that's because it's just a wrapper for a lot of those functions. So for instance here, I have a route called echo. You know, it takes in an echo variable from the query, right? Because it's a GET request. It then calls the echo function that I wrote in iteration 1, right? One of these two here, doesn't really matter. And then after it calls that function, it gets the result of that function, and then it checks about the result of it. If there's an error, it returns the status 400, which we talked about last week, and then it returns a JSON of the response anyway. So you can see here how all we're really doing is like just channeling the input, taking the output and channeling it out. And this is actually how much code you'll end up writing for a whole bunch of stuff in iteration 2 anyway, you know, that you already had written in iteration 1. Now that's on the implementation side. If I look at the testing side, obviously in iteration 1, you've written some tests like this, you know, some kind of jest, describe, whatever. In iteration 2, you will need to convert your test somehow to this style that we have talked about back last week as well, where you still have the same kind of jest, describe, test stuff. It's just here, previously what you might have done is you might have gone like, well, Let me try and give you an example. Value equals body object dot value, right? So let's imagine you have some code like this. In iteration 1, all you would have done is basically said, like what we did here, echo.test. You would have said, yep, we'll let echo be this. Yep, that would be your test, right? Value equals echo hello, expect value to be hello. What we're saying is, okay, when it comes to iteration 2, you simply have to replace your calling of the function to your calling of the route now. Because what you did was you went and modified your server to have like a /echo route. And that /echo route is now what you call, and you pass in hello to it. Now we've got all the code is templated and provided to you. You know, it's not like we're hiding anything, or we have much more to kind of take you through it. But yeah, that's kind of the main element of the migration aspect there. So when we say testing the interface, we're simply saying, hey, you actually have to go and test the server now. Because the way we'll run your test in iteration 2, we'll run your test that tests the server. Okay, you can go read this in your own time. I don't think me going through this will make a great deal of sense right now. And I would just read it out to you as it's written. But obviously people have questions about that, you can ask. Continuous integration. So in this project, there is a .gitlab CI file here. All this will do by default is run the tests that you have in your repo. So it'll just be running the tests against the server. This is all the stuff to do all the testy stuff. All this really does is like spools up a server, runs the server, tests it, kills the server, things like that. And we do say to you that you need to update the GitLab CI file to add npm run lint as well. We leave a little bit for you to do just so that you can get some practice. Basically saying that early on in your iteration, you should lint your code and then add the npm run lint to your pipeline so that your code is now linted. I would recommend that you do that as soon as possible because it will be easier to lint code ongoing than to try and do it all at the last minute. Section 4.7 says storing data. You're required to store data persistently in this iteration. We just had a lecture on that. It just means that your data store needs to be saved now on the file system. Now, a lot of this stuff, 4.8, 4.9, 4.10, 4.9, 4.10, and what, 4.11 and 4.12, and yeah, we'll kind of come back to those because we want to look at the code a little bit more. But I'm just going to quickly jump to the marking criteria so you have an overview of things. The marking criteria for iteration 2 is thankfully really, really similar to iteration 1 in the sense that you got a whole bunch of marks for auto marking. The only difference here is that some of the marks now also include linting as well. The other one is test quality. So yeah, there's test quality, general code quality, Git, and project management. It's actually really similar again to iteration 1, except in iteration 1, the auto marking was slightly less and the Git stuff was 30%, whereas now it's like 20. So it's just a slightly larger emphasis on auto marking, which again does include the linting. Otherwise, things are broadly the same in terms of the requirements here. You'll also see that the formula has been updated for the auto mark. It's no longer just 95 times, it's no longer just the like your tests against your code and our tests against your code. That's 95% of the mark instead of 100%. 5% of the auto mark now comes from linting. That 5% mark is an all or nothing mark. You either lint the code or it doesn't. There's no kind of middle ground. There's no like, oh, we linted 99% of the code. The reason for that is because linting is something that you can easily get 100% right before you submit. So if you didn't get 100% right, you didn't do the job. That's the crux of it. We also have a dry run in this iteration, just like previous iterations. You can go and run it by just going into your project backend repo on a CSE machine and typing in 1531 dry run 2. Just like iteration 1, that will test some really basic examples. It's mostly there to help you double check you didn't accidentally give yourself a 0 in the assessment. That's the main thing. Cool. Well, that's kind of like a lot of the metadata. Let's actually talk about the thing itself. So if we come here, you'll see that it says implement and test the HTTP Express server according to the entire interface provided in the specification. We have a file here that outlines 2Hacks API. This is a file that's kind of agreed upon between the people working on the back end and the front end. So that's kind of what you're implementing. Now, how this is broken up is into two sections. The first section says iteration 2 work that's using iteration 1 work and new iteration 2 work. And what this means is that all of these routes here are just URLs that you will create in Express that are wrappers of things in iteration 1. And what I mean by that is, let's take a look at the admin auth register route. Well, I'm going to now go, and let me just maybe put this on the side here. So like, I'll go open this, and I'll go open my server. And let's say I was working on this project, right? Forget all the git commit stuff, just getting the basics down. I would say, well, it's a post request, clearly, /v1, admin auth register, makes sense, request response. I'll do the TypeScript later, maybe next week. And then I can see that, well, we take in a body, okay, with those properties. So I'm going to take in an email, a password, a name first, and a name last from request.body. Okay, sounds good. And then I need to return a token. So I need to return token, something like this. Yep. And then I think, well, I've already written the admin auth register function from iteration 1. So all I'm going to do here is say, well, const return equals admin auth register. And what do we pass in? Email, password, name first, name last, like that. And I would then go and import this. I would say, well, I got to import this from auth, like that's where the file is. I don't have it here in my copy of the code. And then I know admin auth register from iteration 1. What did it return again? It returned like auth user ID. Okay. So I think, okay, well, I need to do a little bit more there, but let's just say for now it returns return.auth user ID. So now you're done. You've just finished that route. Now you obviously need to kind of modify your tests and stuff, but the purpose of me showing you that is to kind of say, all these routes here are just wrappers of the work you've already done. So they should be pretty easy breezy to get through. How they would typically work, if I were you, is you would go and write your tests first. So for instance, if I had a file, I might go and create a new file called like auth.test.ts. And then I would go and steal code that we gave you, like this one here. And I'd be like, yeah, that code looks good. And then I'd open up my, auth.test.ts and I put this in and I would say, yeah, I'm going to go and request, I'm going to go make a post request to v1/admin auth register. And it's going to take in a body, and that body is going to contain, an email of Hayden at UNSW, and it's a password of, 3, 4, 5, 6, 7, 8, etc. Right? Like you will go and, but you already have the test for this stuff. Like you'll just go and take it from iteration 1, and you'll capture the response and you'll deal with it accordingly. So I'll be like, yep, well, the response from that, I'll get my auth user ID or something like this, and I would check that my auth user ID is equal to 1. Now, obviously, this is a bad test because black box testing means you can't check that the auth user ID is 1 because it's somewhat implementation defined. So yeah, that's good. That's it. That's the crux of all this stuff here. It's just wrapping it. It should be pretty straightforward. All of these routes here will probably be like 20% of the work, if that. Maybe it'll feel a bit hard for the first few as you're getting your head around it, but you've kind of already done the meat of it. You're just trying to restructure the code slightly. These ones at the bottom here, though, are actually totally new routes. And that means that you're going to have to approach them from scratch, which means you're going to have to go and write whole new tests about logging out. You're going to have to write whole new tests about admin quiz trash. And then after you've written that, go and write the implementation for it. But it'll be the same thing. You're writing like just describe, test, some stuff. It's just you have to kind of write this. I would take these and put them in helper functions. That can be really handy. I would simplify this down. We talked about that, I think, a little bit in week 3 as well. And then you go and add more routes. And the cool thing about the Express stuff is it can actually be pretty easy to test because let's imagine that, you've got this little route here. You can open up your API client and you can go and write stuff in. You could be like, yep, well, port 3200 v1 admin auth register. And you can go and just like poke it and play with it. It's very straightforward in that sense. But this document is all about the API. It is the replacement of this table that you had in iteration 1, wherever that table is. Yeah, so this table had all the info for iteration 1. This one has it for iteration 2. Probably the only subtle thing you need to do again is if your route throws a certain error, then you need to capture that and respond accordingly as well, as you'll see there. Stop Breathing says, will we be marked on how concise our code is, i.e. using functions such as map filter reduce instead of typical C code? Some function implementations in iteration 1 of my code weren't JavaScriptified, and I was wondering if we should rewrite the functions. I wouldn't say I'd say generally speaking, your tutor's going to mark your code quality. I don't think strictly they'll be like, I need to see a map reduce and filter. If they see you do stuff that's pretty verbose, it would be a good time to refactor it, yes, because that will come into the marking. I mean, if you look at the criteria, styles described in section 4 and all lecture material, yeah, so I would try and do a little bit of that at least. The main thing is your tutor just needs to kind of glance at your code and not think, oh God, that's super complicated or confusing. They should have just done this. But what's helpful is you can kind of talk to them in your lab this week too. Dylan says, what API client are we to use for iteration 2? It's really up to you. They all do the same thing. They really do. It's like web browsers. They all have the same functionality. So it's kind of up to you. We generally recommend the advanced REST client, particularly on CSE machines, just because it's simple. It's really, really simple. And we have a command for you to run it, which we went through last week as well. So, but it's pretty open season otherwise. Yeah, so this is the docs. It contains everything. Most of these docs are broken up pretty methodically into here's the route, here's what stuff gets taken in, here's what you respond with. Typically GET requests don't have as much given to them, but they respond with a lot, and a lot of the post and stuff requests don't take a lot in. So they take a lot more in, but they don't respond with much. That's just kind of correlation. Yeah, there's a lot of information here. A lot of this I wrote myself actually a couple years ago. So a lot of time is spent making sure that it's really descriptive so that you're really clear with stuff. So there's no point me again dictating every element of that. But that's the bulk of the iterations, implementing and testing that express server as defined in the stock. That's the core of it. That's what we auto mark. We tell you that you can wrap stuff, so it should be pretty easy. You need to implement persistence. This stuff we talk about soon. That doesn't really matter too much. This is just repeating ourselves. This is reminding you not to touch files that you shouldn't touch. I think probably the main thing to flag is that all the functionality you wrote in iteration 1 is identical, except for at least what the spec says. I haven't touched the project in a couple of terms, so maybe tutors have modified it or something, but they probably would have updated the spec. Here, it's that the delete function you wrote in iteration 1, if we go and check that out, quiz remove, it permanently removed the quiz forever. Whereas in iteration 2, you'll see that we made a note that says deleting a quiz now requires that the item is moved to trash instead of permanently deleted. You should be able to totally reuse all of your functionality from iteration 1, except that route you will have to modify, because if you have a look at the routes in iteration 2, you will see that delete here sends it to trash. And then we have a new route around trash that's viewing what's in the trash, restoring stuff from the trash, and emptying the trash, which is pretty straightforward. Now, I want a quick pause before we go through the other sections, 4.8, 9, 10, 11, and 12. Are there any questions people have so far? Is trash going to be additional array and data store? It's really up to you guys. That's an implementation detail. Will the server be local for now? Is it still on localhost? Yes, it's all on localhost. So it's all just running locally. Okay, just tackling a few of these in some different ways. There is a repo that you should be able to access called Project Frontend. This is a repo that you can go and download and run the front end on your machine locally. It's pretty straightforward to go and do. The purpose of that is that if you run your backend and your front end on your machine locally, you should actually be able to have a full app. There is an example of this app here that you can go and log into. Should work fine. I don't manage this, so why is that not? Oh, there we go. It's just slow. So you can actually go and see what the manifestation of 2Hack looks like. You can go and create a new quiz. New quiz might be called like something random. Go and create a quiz. There we go. I want to add some questions. Oh, cool. Yay, lots of questions. Let's add another question. There we go. Save question. Question updated. Right? There's my quiz. Made a new quiz. So this is an actual interactive app. And how this is working is this is literally based on, it's like a student server behind the scenes talking with the front end that the course maintains. It's a very light front end. I don't maintain it anymore, but I wrote the initial version of it a couple years ago as well. I have a 4-hour YouTube video of me speed running it. If anyone wants it, I've never shared it with anyone. I did it just in case it was going to be useful, but then I was like, actually, it's kind of boring. So if you're interested in front end someday, let me know. But it's just a front end that talks to a server. So this front end is code that we don't cover in this course. You don't need to write any code like this, but it's powered by the web server. So you can do this by like on your own local machine. You can go and clone the front end repo over here, run it up so it's running. And then you run your server over here and they talk to each other. It's all very straightforward to set up. But if you try to do that today, it's not going to work because your server isn't finished. So the front end will try and do something like today, like say register or log in. And the front end will be like, hey server, it's time to register. And the server will be like, bet, I can't do it. So the front end's a great thing to play around with towards the end of iteration 2 once you have finished all of your work. Because once your work is finished, it should work. And it's another great litmus test as well, because obviously like you're guided by your tests in the sense that if you pass your test, you think you're doing it right. But your tests are always, again, at the mercy of your prejudice when it comes to interpreting the spec, because you might have interpreted the spec wrong. There's nothing in the front-end repo on GitLab yet. I don't know. Can you post on the forum about that? I don't manage this repo at the moment either. So post on the forum if there's an issue there. I'm just not too sure. Might be a permissioning issue. The team will look into it if people have access problems. So, you know, back to the thing. It's like your prejudice about how you interpret the spec might cause you to write bad tests and then you pass your bad tests. And you've all probably seen this in iteration 1 because not everyone got 100 in iteration 1, but nearly like 95% of groups passed all their own tests, right? Which is a great indicator of how you can write tests that you think are right but are wrong. And then it gives you false confidence. So the reason the front end is good is because when you kind of get to week 7 towards the end of your, testing, I guess, and you're like, we think we've nailed everything. It's like, well, okay, sit down and actually try it out with the front end. And if things aren't working in the front end, that should give you some clues that maybe you should double check some stuff. That's kind of the purpose of that. Recommended approach. We did actually kind of talk about this at the start, which is like write your HTTP tests first. These will fail as you've not yet implemented the routes. That makes sense. Implement the feature and write the express endpoint. That makes sense. Run the tests and continue following everything else. So that's just kind of what I've been talking about earlier. We also mentioned this last week about versioning. A lot of the routes are labeled with V1. In iteration 3, you'll see some routes labeled with V2, and you will be expected to maintain both old and new route versions at the same time. That's not something you need to worry about for now. It's more like just flagging again. Keep an eye on it. Think about it. Most of the work for that comes later, and even then, it's not a great deal of work. but it is probably something to just very lightly consider. Trying to think, like, how would I explain it? So when you write routes and the underlying functions, just remember that we might change small aspects of things for iteration 3 that require you to reuse some logic. Though, to be honest with you, as I say that out loud, I think that's going to be very hard for you to preempt. So I probably wouldn't overthink that too heavily at the moment. Maxwell says, why would we need to maintain outdated code? That's a great question. We kind of covered that in week 4 when we talked about versioning last Tuesday. The crux of it is that when people create new functionalities in pieces of code, they have to support the older versions for a while, because the people who are using their capabilities don't just change it overnight, if that makes sense. So yeah. That's also not too complicated. The two kind of more complicated things we need to talk about, though. First one is error returning. So what you'll notice is that in iteration 1, all of your functions just returned error, just the text error. The object error, I should say. So it was like an object with error and then an error string. In iteration 2, whilst your underlying functions can still do that if you'd like to, where we have to be more thoughtful is that there are 3 types of errors that can occur. Let me get the Swagger doc up again. I think I closed it by accident. Cool. So for instance, we might have a route like this one, description. And you'll see that there are 3 types of errors that can occur: a 400, a 401, or a 403. Thankfully, most errors are 400 errors. So this should be really, we'll come back to 401 and 403 in a sec when we talk about tokens. But the point is, in a lot of your Express servers, you might need to have a little piece of code like this. It should be pretty smooth because, as I said, like the vast majority of errors are going to be this 400 thing. You'll see in different routes, like there's like, oh, here's all the 400 errors. And then this route's like, here's all the 400 errors. So a lot of it will just be kind of writing that code in different spots before sending, the actual, result, because you have to send the error back. This kind of is the key part, though. It's like you can't just send the error object back. You need to associate it with a status code, and we talked about status codes last week as well. Last section, which is the big one that kind of takes a little bit to unpack, 4.9, which is to do with user sessions. So in iteration 1, when you logged in or registered, what you got given back was an auth user ID. There are problems with that approach. One of the problems with that approach is that it's difficult to invalidate someone's validity as being logged in. And what I mean by that is like, if you register someone and you get their auth user ID, that is their like hall pass. That's their badge. That's their boarding pass. That's what they keep using to get into somewhere. And if they know it, how can you ever stop them from accessing things? I.e., you can't really log someone out. So what I mean by that is like, when you board a plane, you don't show them your driver's license, your ID, your user ID in life to get on the plane. You show them a boarding pass. They give you a boarding pass after they check your ID, right? You go to the desk at the airport, you say, here's my ID. They go, great, thanks, here's a boarding pass. They give you like a momentary access to a plane, a particular plane that once the flight's over, the boarding pass is useless, or they can cancel your boarding pass anytime. So that when you turn up to the plane, instead of just showing them your driver's license, they're like, no, I need to actually show me your boarding pass. And that's obviously super valuable, because if all you needed was your driver's license, how would they ever be able to stop you hopping on a plane? You could just like they don't really know. Like, well, it's Hayden. If our check is like, is it Hayden? Then how do, like if we know Hayden can fly, it's like a little bit complicated. So the way we try and get around that is by creating these like temporary passes, if you will. In iteration 1, we didn't have a notion of that. In iteration 1, we were just using auth user ID. This meant there was no way to log someone out because we weren't issuing any passes. In iteration 2, we want to issue something that abstracts their user ID into the notion of a session or a pass or a temporary thing. This way, a single user can log in and log out. So they can log in, instead of giving them back an auth user ID, we give them a pass. They use that pass to give back to us. And once that pass expires, e.g. if they log out, we can disallow them from accessing anything anymore. This is also important for a few other reasons. It also means like if they log in on their phone and their laptop, we have two different passes. So if they log out on their laptop, we can kind of, their phone pass is still valid and vice versa. So it's a pretty fundamental concept. It's not really something new. And I'm sure a few of you thought about this, you know, whilst you were doing iteration 1, which is like, I don't really know how we log someone out now. Because if you give, like, what are you going to give a logout function? An auth user ID? Okay, that'll just log someone out everywhere. And that's assuming that you've kept like a list of user IDs somehow. Because yeah, of course, in iteration 1, nothing would stop you from being like, well, if here's your data store like this, and you've got your users and you've got your quizzes. And let's imagine that you say, you know, I have a user, email might be like Hayden@UNSW, right? And then I say like logged in as true. Maybe that's one way around it. That's the way to do the driver's license approach. It's like, great. So when someone tries to access a quiz route or something else, I check the data store and I see if logged in is true. And if it is true, I know they're logged in. And if they log out, I set that to false. But again, the issue with that is it wipes out everything. You can only really work in one location at a time. Sometimes that's a useful thing. There are some apps out there that do that. I'm trying to think of one off the top of my head. Some banks will do that where like if you log in somewhere else, it like kills you on the other app, but they don't really do this approach either. They do sessions, they're just tighter on it. But the point is we need a way where someone can log in on a laptop and a phone and we can log one of those out independently. That's the main thing. Uzi says, to implement user sessions, do we need to alter the functions we wrote in iteration 1 or can we do it all in the wrapper? You can pretty much do it all in the wrapper because how you can think about it is, let's imagine here, you've got this from iteration 1, right? Or yeah, let's imagine there's a separate route. Maybe it's like a get. Let's say it's a get for quiz or post. Sure, post new quiz. So I come along and I'm like, okay, well, app.post v1 admin quiz, cute, and then we're going to capture from the body. What are we going to capture? Token, name, description. Now, the funny thing is that your function called admin quiz create, I can't remember what it's called. It probably took in, let's go figure it out explicitly. It took in auth user ID, name, and description. And you think, okay, well, that's good. But the problem is I've got this thing called token now. Okay. Well, I can't remember what it returns. It returns an object with quiz ID. What does this want us to return? An object with quiz ID. We can literally just return that straight up. So it like very straightforward. However, there's this point in between where like this here's like your session ID. So yeah, you do need to kind of like create a function that converts token, i.e. session ID, to auth user ID. So to your question, Izzy, about do we need to alter the functions or can we do it in a wrapper? You can do it in a wrapper, I'm pretty sure. I can't see why you couldn't. Because all you're really trying to do is like take someone's boarding pass and map it to an ID, you know? And like your job, like if the boarding pass is valid, then you do the ID fine. And if the boarding pass is invalid, then you don't let them continue. But let's just carry on with that for a sec. Cool. So in iteration 2, we need to adapt it somehow. Instead of passing in an auth user ID into our functions, we will instead pass in a session. Then on our server, we look up the session information, which turn to, you know, identify the session as valid. Now, where I've got to be tricky here is there's a term called token. In the specification, you'll see that the word token is used, not session. When we send HTTP requests, it's a really common practice to describe a string that represents the user's session, their boarding pass, and call it a token. You can see these tokens everywhere. For instance, if let me just pull this up somewhere else. Like if I even just go to the forum, the 1531 forum, you will see that when I refresh this page, there is literally a token I have that my browser sends. Bloody hell, what's it called? File, that's what I want. Yes. Threads. You'll see that there's a token that gets sent. It's quite, damn it, I gotta log out now. Someone might copy that. So I just gotta do this before someone copies it now. Here's the token. This is the token for me to connect to Ed. That's my password. That's like my auth user ID. If you stole that, you could imitate me in Ed. So I'm gonna have to log out now because otherwise you could copy that in. I'll log in later and I'll get a different token. That's how they work. That was a random string that identified me. It was my boarding pass. When I log in again, I'll get a different one. If I log out and I log in again, I'll get a different one. That's what they are. They're very, very simple idea and they identify me. So when we say token, we are truly just referring to some kind of uniquely identifying string that represents the session. It just so happens that the easy way that we do tokens in this course is using JSON, you know? So it's like with JSON, I can, for instance, I'll show you how to create one. Let's get a random file here. I might say, well, let's imagine that we're writing, I'll kind of write the code for you. Yeah, go change my profile picture. That'd be great. Let's imagine I've got my little app.post here, right? Okay, cool. Now I know that when, you know, it returns this, I say auth user ID equals return.auth user ID. This might be my admin auth register. I know it returns a user ID. Where I might have to make some modifications, right, to my previous functions potentially. You could do this by wrapping it if you want to, but if I go inside, like where would my implementation be? I don't have one because we don't want to give answers away. But let's imagine we have our auth user register function, right? Takes in like name first, name last, takes in all this stuff. You have the usual things where you say, you know what, if like we'll say like const data equals data store like this, right? Pretty easy. Then I go if data dot emails dot includes email, or however you've done it, right? Lots of you will have done things different ways. Object dot keys. I'm just making up random code that might resemble. Here you'll say return error, return object error, user already registered, right? You know the drill. You'll do something like that. Later on, you might have done something otherwise where you actually say like, hey, well, const user ID equals random number. You might generate a random number. Then you might get your emails and you might add a new email to it. And you'll say that, yep, okay, its password is password, its name first is name first, and its name last is name last. That might have been all that you did. However, what you might be doing now, when you register a user, is you might also then say, well, sessions here, they're going to have a bunch of sessions. They could be logged out, logged in nowhere, 1 place, 2 place, 10 places. So I'm going to go create a list. And what I'm also going to do is say, well, because they've just logged in, I need a new session ID for them, which might be another random number. Okay, cool. And that might be like, think of a random number like this. And then what I do is I say, you know what? Here is one of the session IDs. And then what this function will return now is it might return a session ID instead. Now, again, you can always pause this video and go stare at it for a bit. But the point here is that what I'm doing now is instead of returning a user ID, I might here return a session ID. Now, there was this question about, do we need to alter the functions we wrote in iteration 1? And I kind of said no before, and I don't want to confuse you. You might need to alter register and login, but the rest of the functions you shouldn't need to alter at all. And even register and login, you could create separate functions if you really wanted to. Like you could create a separate function that's like add session for user based on the user ID. So you don't need to modify it. I probably just would for simplicity, but it's not required at all. So now your auth register function returns a session ID instead of a user ID. And then your route in the server, now normally these would be in different files. I've just got them in the same place here for simplicity. Make this a little bigger. Now your route will simply take the return thing and it'll be like, yep, response.send. I guess I'm just sending back, you know, I could make it more explicit for you. It'd be like session ID, return.session ID if you really need to. That could be it. So now when someone registers, they get a session ID. And you know what? What happens if someone logs in? Let's do the rodeo a second time. So when someone logs in now, I'm going to call admin auth login with just an email and a password, right? Pretty easy. And then I've got my other function here, admin auth login, like this. I go get my data store. I do the usual checks. I like check like, does email exist? Is password correct? And if it is correct, well, I don't need to go and create a new email object anymore. But you know what I might do the second time? I don't need to create a new user ID either, but I need to create a new session ID because they've logged in. And then I'll say data emails. For that particular email, I want to get the sessions and I'm going to add a new session ID to it. Because we've just got a list of session IDs. And then I return that new session ID as well. And then if you think about it, let's just imagine for a second, I'm really giving you a bit of a helping hand here. Let's imagine I go and create a new function for logout. And logout doesn't need to take in any, well, it needs to only really take in the session ID, or the token, I guess you'd say. Let me come back to that one. So that's how we create the session IDs and return it to a user. However, we don't call this session ID, we call this token. This is where things can get slightly confusing. A session ID is just a number. That's it. It represents something specific to our application, specific to our implementation. However, if I go look up register and stuff, it actually returns a token. And the idea here is that a token should be an object that is stringified down. Now, you might not, that is actually, don't listen to that piece of code. I'll confuse you if I try and explain it that way. How you do this is really up to you. I would probably recommend that you have your token structured like this, because here's how to think about it. Auth register does have the side effect of logging you in, yes. Here's how to think about it. The token is a big object that might contain a lot of information. It just happens to contain a session ID. There are some people in this course who use a token that has a session ID and a user ID at the same time. You can do that. It's really up to you. You can have it contain extra stuff if you really want to. It doesn't really matter. The main point we want to leave you with is that the token is a string that contains information that the user needs to bring back to you to prove it's them and that they can do this thing you want to do. So if you think about register and login as, you know, the user comes to you, the server, and says, here's my credentials, here's my driver's license. You go, here's your boarding pass, back to them. They take that boarding pass. The boarding pass is called a token. It's got lots of writing on it, right? Lots of writing. And they then go away with that. And later on, they come back when they want to hop on the plane. They hand the boarding pass to you. You look at the different pieces of writing on it and you go, oh, okay, yep, I can see it's you. Great, let's keep going. It just so happens that the amount of writing you need on the boarding pass is typically just the session ID. You can add more, but I would structure it like this because I think it helps demonstrate the concept. Students do it differently. It doesn't really matter. The token's a string at the end of the day. It gets stringified, so it doesn't really matter. So, you know, you kind of come away, there's your token. It has to return a token because that's what the server says we have to do. Sweet. Now someone comes along and they have another route, such as the quiz create route. Okay, so what do we do on the quiz create route? Well, we know we have a token now because they're passing us back a token. And what do we know about a token? We know that a token is an object that contains a session ID. So I could here say session ID equals token.session_ID because I know I packaged up that little piece of writing on the token. That's what we were doing up here. And then I go, okay, now I need to get my user ID from the session ID. So I might create a helper function and I'll say like auth user ID equals get user from session, and I'll pass in a session ID. And I'll come up here and I'll create a new function called get user from session that takes in a session ID. And then I probably wouldn't do this in the server file. I'd do it in a separate file. And I would, I'd be like, well, data store dot emails with data stored at users, I might have to loop through them, right? So I'm like, oh, right, I've got to get everyone's emails, say. So now I say like, loop through every email of all of our emails. All right. Now for each one, I'll be like, well, if data store.users email.sessions includes session ID, you know, basically I go through each user one by one and I check, does that session ID exist? Then I will just return data store.users email.id, perhaps, or auth user ID, or whatever the hell you called it, right? And that's the function, and otherwise it will return null. Didn't find it. Session's not valid. Sorry. Now, you don't have to store it like this. People store this very differently. Some people store the sessions forever. You know, they store them forever and they simply have extra metadata to be like it's logged in, logged out. Some people delete sessions. Some people create a whole other part of the data store that has sessions on it, where basically it's a big object of like a particular session ID just maps to a user ID. And they use that to look it up, you know? Like there's lots of different ways you can do it. You don't have to do what I'm showing you here. As long as it works, that's the main thing and it's not, you know, overly complicated. But the point is, I say I have that get user from session. Cool. Now I have my auth user ID. Now I can go call the same functions. We can do the same thing here. For instance, if someone wants to log out, admin auth logout. Cool. What are they going to pass in? They're going to pass in just a token. And if they pass in just the token, well, I'm going to have my new function called admin auth logout that takes in a, well, that one probably will take in a token or a session ID or whatever. Like you can, again, define it how you want, because at the top level in this iteration, we're only really testing the routes, the HTTP server, not really testing anything else. Like from an auto marking perspective, it only really knows what it gives a route and what the route gives back. All the stuff in between is just details. The kind of last point for completeness I have to point out is that we did talk about these errors here, error returning. And I mentioned this in the spec too, that there are some routes that have many types of errors. Like this one. No, what one has a few errors? 401, 400, 400. Oh, no, there's. Well, okay, so this one has 3 errors here. Now remember, anytime the user gives you a bad value in general, you're going to return a 400 error. And there's a long list of them. But there's 2 other errors that we're specifically going to throw. 401 if the token is empty or invalid, right? And 403 if the token is valid but the user does not have access to it. So let's imagine for a second now, someone tries to create a quiz. Now let's say the token's invalid. Well, if the token's invalid, I'm going to know because auth user ID is going to be null, because that's how I wrote it above, like if the token's not a valid user. And then I can simply do my usual, like, you know, 400 status res.send or res.json, you know, error, and then I'll be like, what's it? Unknown type string error. I don't actually think that's meant to be the error message. I feel like someone screwed something up. I'll ask the course about that. That looks like the doc's having an error. Maybe. I don't want to be presumptuous, but, you know, so I'll do that. And then it's like, okay, well, what if it is valid? Well, then I might be like, well, for them to create the quiz, maybe in the last iteration, you did a thing where you checked about whether they were able to create that quiz. And what this could be a good idea is maybe separate out some logic here. So now I'm actually going to say, well, owns quiz. I'll create a new function. I'll reuse some logic from iteration 1. And I'll say like admin quiz owns, where I give it a quiz ID. Because obviously if I'm, well, this is maybe not the best example. Let's imagine that it's like a get. Someone wants to access a particular quiz. Admin quiz get, if you will. You know, you want to check if they own the quiz. It's like, well, really butchering this now. Not much time left. Normally we don't go into this much detail, but I'm trying to really get the point across. Someone wants to get details about a quiz ID. Okay. So then you say, well, I want to check, does this particular auth user ID, which we've already validated as a real user, do they have access to this quiz ID? All right. And if they don't own the quiz, then what are we going to do? We're going to do the same thing. We are going to go and say, well, 400, well, this one, sorry. I butchered that. That should be 401 and this should be 403. These are the two things you'll have to check for in some routes. A 401 is always the same thing in this project. It is the token valid or not? If it's not a valid token, if it doesn't refer to a valid session, it's a 401. If it is a real person and a real session, the next thing to check is, are they allowed to do the thing they're trying to do? And let's imagine, I'm not saying this is how the project works, but let's imagine that you want to view a quiz and you can only view quizzes you own. Well, we need to do that check. And then what we do after that is we go get the data. And if anything else is wrong from there, then what we'd probably do is have our, 400 errors at the bottom here, in this case. But that's what you'll typically see. A lot of your functions will have a very similar pattern to this, which is like, you get the token, you decode it into a session, you get the user, so you know who it is. If they BS'd you with a session, you throw a 401. You then check if they can do the thing they want to do. That's not on every route, because obviously, like updating a quiz description or a quiz name, you need to make sure that you're permissioned to do it. But to say like viewing what's in the trash, kind of everyone can view the quizzes in the trash. Or like more specifically, it's not really like everyone can view all the quizzes. It's like, there's nothing really they can give you wrong. You know what I mean? Like if someone says to you, like if you say to the airline, if you go to an airport and you talk to the airport examples and you say like, hey, what seat am I in? They look at you, they go, up was your boarding pass. Up, there's your seat. They're not going to tell you anyone else's seat. You can't, tell them anything that's really going to stop them, giving you the information for you. So it's like that for some of these items. But the main takeaway again is that the 401 and 403 errors are very easy. They're always the same thing. Once you solve for it once, it's going to be pretty easy to reuse a lot of the logic as well. Where does the 401 naming convention come from? Remember that it comes from the HTTP status errors say that any error that starts with a 4 is the user made a mistake. So 401 unauthorized is like the user made a mistake by giving you the wrong token. 403 is like the user made a mistake by trying to do something they weren't allowed to do or don't have access to. And 400 is like they gave you bad input. I don't know why it's a 4. I guess that's just how the world panned out. There's some cool stuff that you can do with some of these with higher order components. I won't talk about those today because we've run out of time. But are not necessary at all. I know this is a big dump of information today. I don't want to spook anyone just in closing, because like this lecture in particular has been pretty fast, like smashing through stuff. A big part of that's just because I've gone through an exceptional amount of detail compared to previous terms. Normally I wouldn't spend, typical term, I wouldn't spend this much time writing this much code out. We'd kind of more explain things at a high level. So it's been felt a little more chaotic, just trying to get a lot of stuff down, but I hope it has been helpful for people. Even if it doesn't make sense now, I'd really recommend people go and do like the week 4 and 5 labs, get them done, and then go have a look at this again, because I think getting a bit more practical experience will give you a heads up. But my last comment just to all of you today is iteration 2 is... It's really hard if you start in week 7. Like, not to sound too sentimental, but like, if you, like, my job this term is to turn up and lecture for UChat sometimes. If you have a bad iteration 2, it's going to have no effect on my life at all. So I'm not telling you this because like I have a vested interest in it. I'm telling you this because I've taught this course a lot and I've interacted with a lot of students. As much as humanly possible, start iteration 2 meaningfully by the end of this weekend. Get at least 20% of it done this weekend. If you don't get it started this weekend and you don't get everyone doing at least a little bit and a few commits and merge requests, next week will fly by because you'll all be tired and exhausted and just need a bit of a break, and you've got week 7 anyway. If you let week 5 weekend slip by, you'll let week 6 slip by. And then suddenly you'll worry. And if you get to the weekend of week 6, you know what you're going to be spending time on? Probably the stuff due in week 7 on a Monday. Really quick tangent before we wrap up. For years, iteration 2 used to be due on week 7 Monday. We moved it to week 7 Friday. Do you know what ironically happened? students started performing worse when they had more time. The reason that we postulate that students were performing worse is because we know that a lot of assessments compete in week 7 for time for students. And a lot of students had things due early on in week 7. And that's problematic because you don't want to think about this week. I get it. I've been there. And then next week it's like, damn, I should really do that thing due on the Monday of week 7. And then there's always maybe like 30% of groups or something that kind of really don't awaken themselves until Tuesday of week 7. And at which point, if you're kind of not at least 2/3 through it by Tuesday of week 7, it just makes week 7 miserable. But I'll just stress again, I don't want to pretend as I was not a good student, and I don't want to be all like, oh, just like pace yourself and get a little bit done every day. All I say is start it soon. If you do 20% of it in the next few days, if you just get in and do it, and then you leave it for a week, you'll be like infinitely better than everyone else, because once you start it, you'll know how to think about it and approach it. Because starting an iteration like this is the hardest part. I would do it in the lab, find some time with the group, organize a call, stay on the call till stuff's done. Even if you're all kind of half distracted, just stay on the damn call till 10 p.m. or something. Whatever it is, whatever works for your group, just get in, get stuck into it. Though I would probably still recommend maybe doing the lab first, because the lab I think is useful prerequisite knowledge, which is why I say the weekend. I think the weekend's really reasonable. I know what it's like. If you try and do it in the lab this week, you're not going to do it because you're going to be thinking about all the other other stuff you got to do. But go get the labs done. You'll get them done on like Saturday or whatever it is. Go just dig into it on Sunday or first thing Monday and just get over the hump, and you'll be cruising after that. So anyway, that's it from me. Thanks for that little tangent that took us over time at the end. Good luck with iteration 2. If you have questions, post on the forum or join help sessions. Tutors are exceptionally useful. They've all done this project before or taught it before, so they can always be really helpful. Otherwise, I'll see you on Thursday.